Hello, welcome back. This is question 3 of the Cambridge Igcse Mathematics written in May-June 2024. This is the third video. If you are seeing this for the first time, please kindly look into the playlist for videos 1 and 2 for questions 1 and 2 respectively. Question 3a. The table shows the time that each of 40 students takes to travel to school. Time is given in minutes and is denoted by m. Frequency for each of the intervals is given below. Calculate the estimate of the mean. Okay, so if you want to get the estimate of the mean, so you need to firstly find the average of each of the class intervals. So let's denote that by x. So we'll take it as letter x. So okay, let's write up here. If this is letter x, okay, let's take this again, letter x. Okay, then it will be the average of these will be 10 add 0, that remains 10. Then 10 divided by 2, that will be 5. Okay, then for this, 10 add 25 divided by 2 will give us 17.5. Okay, 25 add 40 divided by 2, then that will give us 32.5. Then finally 40 add 60, then divide by 2, that gives 50. Okay, so the next thing we need to find is to find okay, this is f for frequency, so we need to find fx. Okay, so the fx will be the product of x and f. So for this we have 5 times 3, we have 15. Then for this we have 17.5 multiplied by 18, so that will give us 315. Then if you do 32.5 multiplied by 15, that will give us 487, then 0.5. And if you do 50 multiplied by 4, that gives 200. Okay, so the estimate for the mean, okay, so denoted by this symbol, will be equals to summation fx over summation f. Okay, so for this you need to add 15 to 315 to 487.5 to then 200. So if you do this, you should get 1017.5 over, so the summation of the frequencies should be 40, okay, as given above. So that is 40. So if you divide this by this, you should get 25.43. So that would be the mean, and you can easily write it as 25.4 to 3 significant figures. So you have 25.4. 3a Roman figure 2. On the grid, draw a histogram to show the information in the table. So we have the frequency density here, and we have the time in minutes. So we need to calculate the frequency density for each of these class intervals. Okay, so let's start with this. Okay, so the frequency density for this will be 3 divided by the class size will be 10 minus 0, that will be 10. Okay, so let's manage somewhere here, or we can look for, okay, I think is, can just do the first one here. So we have 3 over 10, okay, to be equals to 0.3. So this will be the frequency density for the first class. Okay, for the second one will be 18 divided by 25 minus 10 should give us 15. So that will be 18 divided by 20, sorry, 15 divided by 15. Okay, so that will be equals to 1.2. So the next frequency density will be 15 divided by 40 minus 25. That will be 15. That's the class size. So we have 15 divided by 15. That is 1. 15 divided by 15. Okay, that will be 1. And the last one will be 4 divided by 60 minus 40, that is 20. So we have 4, okay, divided by 4 divided by 20, that will be equals to 0.2. Okay, so for the frequency density, the formula is equals to the frequency over the class size. Okay, so that's how to get the frequency density. Okay, so we need to plot this against the given minute, that is time. Okay, so when the frequency density is 0.3, that is, this is 0, 0.1, 0.2, 0.3 is here. Okay, so the class size will be that is from 0 to between 0 and 10. That's the first one. So we can do something like this. Okay, good. Then let's take this down like this. That will be the first one. Then the second one, when the frequency density is 1.2. Okay, the frequency density is 1.2. So this is 1, 1.1, 1.2 to be around here. Okay, so that is, let's take this up a little bit. So 1.2 will be here. Okay, and the class size, let's check the class size. That's from 10 to 25. Okay, so 25 will be here. So let's take it up here. So that is 1, 1.2, somewhere here. Good. So we can now join these two together. Okay, so I hope you can see the lines here. Okay, I think it's better to, okay, let me change the color. Yes, I think it's better like this. So let's go for the third one. It will be when the frequency density is 1. Okay, so the class size will be 32 from 25 to 40. So 25 to 40. So it will be here like this. Let's take this 25 to 40. Then we'll take it down from here. Okay, and the last one, when the frequency density is 0.2, so the class size should be, the range, the class interval is from 40 to 60. 40 to 60, frequency density is 0.2, 0.2, then 40 to 60. So you have something like this. Okay, sorry, the graph is somehow tilting. Okay, so that's why you have something like this. Okay, so this should be a straight line. Okay, so this is what we get when you draw the frequency density against the time. Okay, so let's go to the next question. Roman figure 3. Two students are selected at random from the 40 students. Calculate the probability that one student takes more than 25 minutes and the other student takes 10 minutes or less to travel to school. Okay, so we are selecting two students here. So the order matters. Okay, the first selection and the second selection. So we have to take note of the order of selection. Okay, so if you look at the table, okay, more than 15 minutes, more than 25 minutes will be this, and this. Okay, so we have 19, so that will be 15, okay, plus 4 over total, that is 40. So this is the first selection, and that is multiplication. So the second selection will be the other student takes 10 minutes or less. So 10 minutes or less will be this. So we have this 3, okay. So that will be 3 out of 40, 3 out of 39. So because we selected the first one, so we're left with 39. So it will be 3 out of 39. Okay, so this is one way. Another way is to select this first. So that is or, which is addition. To select this first, that will be 3 out of 40. Then and to select this one next. So 15 add 4 is 19. Okay, so in this case, it will still be this. That will be 15 add 4, then over, then 39. Okay, so let's add this now. So this will be 19 over 40 multiplied by 3 over 39. Okay, so plus 3 over 40 multiplied by 19 over 39. So if you observe these two, they are the same, because here you are multiplying 19 by 3, okay, at the numerator, and also here you are doing the same thing, 3 by 19. So for the denominator, 40 by 39, so we still have 40 by 39, so they are the same. So you can easily say 2 multiplied by, let's say, any one of them, that is 19 over 40. Okay, this is equals to this, so equals to this 3 over 39. So you can simply write this from the beginning. Okay, from here you can simply write this, okay, so that you can get your answer straight away, but it doesn't matter. So just to show you how this goes. Okay, so if you input this into your calculator, so you will get 19 out of 260. So if you convert it to decimal, that would be 0.073. So this is some information about the time that 200 people took to fill in a questionnaire. The longest time taken was 30 minutes. The median time was 22 minutes. The lower quartile was 8 minutes. The interquartile range was 19 minutes. The range was 25 minutes. Write down the shortest time taken. The longest time taken was 30 minutes. Okay, so we want to get the shortest time taken. So the difference between the two, that is between the longest time and the shortest time taken, should be 25. Okay, so if the longest time is 30, so that means the shortest should be 5. Okay, so we have 5 here. So alternatively, you can do range, okay, to be equals to let's say 30 minus the shortest. Okay, so you can do this, and you know that the range is given as that's 25. So you have 25 equals to 30 minus the shortest. Okay, and from here you can get the shortest, okay, to be equals to 30 minus 25, okay, which is equals to 5. So you can get it from here. Roman figure 2 on the grid, draw a box and whisker plot to show this information. So this is the information here. So let me quickly give you the rough sketch of the box and whisker plot. So you have the box like this. Okay, so you have the first whisker, we have the second whisker. Okay, so here you have the minimum, okay, and here you have the maximum. So here you have the first quartile, which is also known as the lower quartile. So somewhere around there, you have the second quartile, which is also known as the median. So here you have the third quartile, which is also known as the upper quartile. Okay, so these are the info we need to get here. So the minimum, okay, that's the shortest time, that is 5. Okay, so we found that. Then we need the lower quartile is giving us 8. We need the median is giving us 22. We need the upper quartile, so that is not given. So we need to find it. Okay, so you can just quickly do something here. So the interquartile range, okay, is equals to Q3 minus Q1, and the interquartile range, okay, is giving us 19. Okay, so to be equals to Q3 that you want to find, and Q1 is equals to 8. So this will be 19 add 8, that will be Q3. So 19 add 8 is 27. So that means Q3 is equals to 27. Okay, so and we know the maximum. Okay, so we have all the necessary parameters, so we can fill this. Okay, so let's start with the minimum. So the minimum is 5. So 5 is here. You can use any height you want to use, no trouble. Okay, so let's take this. This is the minimum. Okay, and the first quartile, that is Q1, is given as 8. So 8 will be here. So that means two steps before 10. Okay, so let me quickly draw a line here to get the height. So I can use 3 lines like this. Okay, something like this. Okay, good. So for the median, that is, the median is given as 22. So 22 will be around here. So I have to maintain the same height. Okay, so 22, this is 21, this is 22. So let's start from here and drop up to this spot here. Okay, I think this is good. Okay, good. So that is the median. So we need the upper quartile. So we just found that to be 27. So 27, this is 25, 26, 27. So sorry. So we still need to maintain the same height. So 27 will be here like this. So drop up to this spot, that is 27. So I can easily do this. Let's join this together. Okay, we have this here, and I think I need to adjust this a little bit. Okay, good. So we have this here. Okay, so let me join this here for the minimum. Let's take that again. So take it from somewhere here. Good. And we are left with the maximum. The maximum is 30. It will be from here to here. Okay, so I think I can adjust this ones a little bit. I can adjust this, then I can also adjust this one here. Okay, so that will be up a little bit. Good. Okay, so this is what we should have. Okay, here is the minimum. Okay, so this way we have the minimum and it is 5. So you have the maximum here and it is 30. Okay, that's the maximum. So here you have the first quartile, that is Q1. Here you have the second quartile, that's the median, Q2. And here we have the upper quartile, that is Q3. So you don't need to label this. Okay, so this is just to explain better. Okay, you only need the box and the two whiskers, okay, by the left and by the right, okay, respectively. So let's go to Roman figure 3. Judge says that 101 of the 200 people took more than 22 minutes to fill in the questionnaire. Explain why is wrong. Okay, already half of the median is 22, okay, minutes. Okay, so that implies that half of the population, that's the middle, okay, half of the population already took 22 minutes or less. Okay, so there is no way you can get any other 101 from anywhere, because we already have 100 people, okay, to be to we already have 100 people who took 22 minutes or less, okay, to fill in the questionnaire. So that means we are left with 100. So it is impossible for 101 people, okay, to take more than 22 minutes to fill the questionnaire. So that is the reason. So here I'll write half of the people. So you can say in bracket 100, okay, that's 100 people, okay, took 2 minutes, okay, or less, okay, to fill in the questionnaire. So let's write here to fill in the questionnaire, okay. So that would be a perfect explanation. So this is the end of the solution to question 3. So in the next video, I will solve question 4. Until then, have your fingers crossed.